All right, Unit 7, Day 4. We're still in trigonometry. Let's go ahead and start with our warm-up. These do come out of the workbook on various pages, but I just figured I would print them out for you. Which of the following is true for angle theta? Select all that apply. All right, so let's think about it here for a second where theta is. Well, which quadrant is it in? It's in the third quadrant. Well, what happens in the third quadrant? Well, both x and y are negative. But when I go here, it appears that this is talking about cosine and sine. Well, remember the x is cosine of theta and the y is sine of theta. All right. So here, the cosine of theta and sine of theta are going to be less than 1. So it's not greater than 0 or less. I'm sorry, less than 0 because they're negative. All right. Not greater than. So they're both going to be less than 0. Now, the question is sine bigger or is cosine bigger? Well, let's look at where this is. Do you see it doesn't quite lie like in the center? The center would be right here. And that would be that point right there would be the point when you have a 45, 45, 90 degree triangle. So it'd be negative square root of 2, square root of 2, negative square root of 2, square root of 2. So that's bigger. But here, or that would be the same. And I don't even see that right there. Okay, but here, do you notice how the y looks smaller? Okay, so the y looks smaller. The sine of theta is going to be less than the cosine of theta because the x value is right here, and that's longer than this one right here. So this is the one that we're looking at. All right, so be able to decipher that. And remember, cosine is x, sine is y. All right, now number 12. Label these points on the unit circle. All right, so we're going to name all these points, okay? Q is the image of P after a 11 pi over 6 rotation with center 0. Okay, so here's P right here. Okay, 11 pi over 6, if you remember. If you need to put the 6, you can. But think about this. If I add one more, that's 12 pi over 6, which is 2 pi. All right, so just remember 11 pi over 6 is about right here. Okay, so we're going to label that as Q. And this is kind of remembering your unit circle. If you need to, we'll have a calculator the entire time. So if you need to, remember our little kind of cheating way. If we hit the wrench, okay, and we hit the circle, now, right now I'm in degrees, but I can go to radians. Okay, and I see 11 pi over 6 right over here in the fourth quadrant. Okay, R is the image of P after 3 pi over 2. 3 pi over 2, okay? And think about this for a second. This is already divided. You got 2 and then 2. So 1, 2, 3. It lands right here. So that's where R is going to be. All right, U is the image of P after two-thirds pi rotation. Well, here, 2/3 pi is actually in this quadrant right here. Okay, and this is going to be U. And again, we can actually double check either one of these. Okay, 2 pi over 3 is right here. All right, and then pi over 3. Pi over 3 is got a mirror image to this one. Okay, and that's going to be V. And these are where all of our points are. So remember where the different radian measures are and the different rotations that you have with the unit circle. All right, here we go. We're going to move on and we're going to look at these parent functions right here. Okay, let's look at these parent functions right here. These are all functions that we've discussed this year. Okay, so you are going to have to recall them for your upcoming tests. All right, well, what do you remember this first one is called? It is called absolute value function. Okay, this is the one where it's a V. Okay, and now the most basic, like it looks like this. The vertex here is at 0, 0, and so forth. And then we shift it left, right, up, down, make it wider, or make it thinner. All right, this is a cubic function. The most basic cubic looks like that. All right. Now, the next one, now this number can change. This says 2 to the x, but it could be 3 to the x, 4 to the x, whatever. This is an exponential. All right, an exponential function. Now, this one is a growth. So this one looks something like that. But we could also have decay to where it goes down. All right. This is called a rational function. All right. This is where we had the vertical asymptotes, horizontal asymptotes, the holes in the graph. This specific function looks like this. All right. I think it looks like that. Let's double check it for a second. I might have it in the wrong quadrant. So 1 divided by x. Yes, I do have it in the wrong quadrant. I change it back. So let me erase that for a second. I always kind of forget where the two things go. All right, which is a good reason why we should also graph it just to double check. All right, sine function. Okay, sine function, we've been talking about that. Remember, the sine function starts on the midline. Okay, and it goes something like this. All right, and then it'll start over. Cosine functions start off the midline. Okay, so this one would look something like that, and then come, oh, Fred, here we go, sorry. Looks something like these two things. All right. Now, as far as transformations and these parent functions, okay, I'm going to write some things out. So like g of x equals a, absolute value x minus h plus k. All right. Cubic function, y, or we'll say g of x as well. A, x minus h cubed plus k. And you're going to see some very similar things in each one of these. All right. G of x equals, and I should probably be changing these up because I changed these up, but it's all right. Now this one is a times 2 to the x minus h and then plus k. All right. Do you see how they all have a, h, and k in it? All right. Here we would have, okay, a on top, x minus h plus k. All right. So sine and cosine, same thing. All right. G of x, a sine x minus h plus k. All right. And we did see, and there's in sine, you have this b value as well. So I'll put the b right there. And the same thing for cosine. All right. It's this a cosine b parentheses x minus h plus k. And yesterday we looked at everything, the a, b, and the k. We just didn't throw h in there. That's something I'm just going to add in today, just kind of quickly, and then not talk much about it because it isn't necessarily part of our curriculum. All right. But remember this, a, okay, when a is negative, okay, that one means when a is less than 0, okay, it reflects over the x-axis. All right. Now, what else does a do for us? Well, when a, and this is when the absolute value of a, because a could be negative. All right. And so we're just looking at a without the negative. When it is less than 1, it's our graph is going to widen. Okay. You may also hear compress by whatever factor that a value is. All right. And then here, what if it's greater than 1? It narrows the graph. Okay. Or stretches. We like to use the word stretches. Okay. Now, what does H do for us? H likes to move, translate. We'll use the word translate. Translate means shift left and right. Okay, and how do we know which way it goes? Well, this one, because there's the minus, you have to think opposite. So if it's like x minus h, it's going to go, or x plus h, sorry, is left, and x minus h is going to be right. Okay, a lot of times when you think minus, it's going negative and it would go left. But in this case, think opposite. Now the k, don't think opposite. This is when it translates up and down. Okay, so if it's plus k, it is going up, or if it's minus k, it is going down. Now, with sine and cosine, we've talked about different things, A, H, and K. All right, your amplitude is the absolute value of A without negative. What the negative does for us, it tells us basically if it's negative for cosine, it's going to start below your midline. If it's negative for sine, after it's on your midline, it's going to go like below the midline. Okay, period. We talked about this yesterday. We have a formula, 2 pi over b. All right, you should have that memorized. Vertical shift, okay, is just K. And so if it's positive K, it's going up K. If it's negative K, it's going down K. And your midline is associated right with that, Y equals K. Now, we don't really talk about H. I'm just going to add this in here just this once. We're not going to add it in when we do the problems, but there's something called a phase shift. If you go on to Math 4 or if you go on to pre-calc, you'll hear this one. Okay, phase shift is just H. That's your left and right or horizontal shift. Okay, so your phase shift would just be H, right? Okay, so let's describe the functions and their transformations from their parent function. All right, well, what is this one? It's an absolute value. So here was its parent function right here. Well, it got an A value of 2. So it's going to, and 2 is greater than 1. So it's going to stretch by 2. And then when I have plus 3, okay, think plus 3 with the x, that means it's going to go left 3. And if you need to, we can graph both of these and actually visualize this. Okay, remember absolute value is underneath here. So absolute value of x. And then here, 2, absolute value of x plus 3. All right, and when I do that, do you see how it narrows? Okay, think about the ends and you're stretching it up. All right, and here it did move left 3. Okay, here a value is negative. So it's going to reflect over the x-axis. Now, x minus 2, okay, that means we're going to go right 2. All right, and plus 5 on the outside means we're going to go up 5. All right, and we translated a cubic function. Now, if you want to pause this and see if you can guess each one of these, you go right ahead. All right, number 3. Here, this is an exponential. Now, unfortunately, this is not necessarily this. We're not translating this because this time there's a 5. So here the parent function is actually 5 to the x. That's what we're translating. All right. So the 5 is not going to do anything for us. We're really just looking at the x minus 3. So that's telling us it's going to go right 3. And then the plus 2. So it's going to go up 2. There's no a value out in front of that. All right. Now here, this is just a generic. Okay, it could be any one of these functions. It just has g of x equals, and it's just translating f of x. All right, so that 3 is the a. All right, it is going to, so since 3 is greater than 1, it's going to stretch by 3. Then x plus 2, that's like right here, it's going to go left 2. And then minus 4 on the outside, that means it's going to go down 4. All right. And now to our trig function. This is a cosine function. All right. So here, the 4 on the outside, okay, that means it's going to stretch by 4. Okay. It's going to go right 2. That's our phase shift, which we're not really going to talk about phase shift in math 3. Okay. And then up 3. Now, the meat and potatoes of this, because we are in the trig unit, let's talk about our amplitude. Amplitude is absolute value of 4, okay, or just 4. Period, 2 pi over b. Well, remember your b values in front of this parentheses, and if I don't see anything, our b value is 1. So 2 pi over 1, so 2 pi. Remember, that means one cycle happens from 0 to 2 pi in a length of 2 pi. Vertical shift, that's up and down right here. We're going 3, but that's also our midline. So we're going to put y equals 3. And you can graph it and compare it to cosine of x as well to see what's going on. All right, let's go to the next page right here. Okay, we're doing some of the same stuff. All right, go ahead and pause it, but both of these are with sine. Okay, pause it and see if you can fill these out. All right, and come back. All right, here, our amplitude is 2. All right. Here, our period, now be careful, this is our B value right here. So 2 pi over 3. That means the length of one cycle is 2 pi over 3. Vertical shift is that out here, so -2. All right. Or you can say down 2. All right. And our midline is that same thing, y equals -2. All right. And let's go actually graph this and see it. Okay. I am going to put sine x. Just make sure when we're doing this, we're like in radians, and we are, not degrees. Okay. And then here, 2 sine of 3x plus 3. All right, -2. And then that plus 3, remember, you're going left 3. That's our phase shift. All right, so let's analyze this and see kind of what's going on. Let me just make it bigger for a second. All right, here we go. The amplitude, and actually we set the midline as y equals -2. So I'm just going to throw that in there. Do you notice that green line is straight through the middle? Okay, and our amplitude is 2. Now, one thing you got to notice, I'm going to zoom out 1. All right, because those boxes were each worth a half. Now, if I do this, each box is worth 1. And so now I see my amplitude from my max to here. So my max is at 0, and then my midline's at -2. So that's a length of 2, or my midline to my min. Okay, it's also a length of 2. So that's my amplitude. All right, my period, that's the length of one cycle. All right, so this one's a little, because it's shifted a little bit, it's kind of hard to kind of tell. You can't really start at 0 because it's shifted. You can see from here to here. If you go and subtract these, so if I do 1.712 minus negative, was that value? 0.382. Okay, you're going to see 2.094. Well, we said it was 2 pi over 3. And do you see how these are the same thing right here? Okay, so our period is the length of 2 pi over 3. It's just you're working with decimals here. All right, so let's go back. All right, so let's go do this one right here. Now, my amplitude, there's a 1 out here. So my amplitude's just 1. All right, my period, 2 pi over 2, because my period, my B value is that. All right, so that simplifies to pi. Vertical shift is this -3 or down 3. Okay, my midline is going to be the same thing, but put y equals -3. And if you want to graph it, you're welcome to see all that, to see if you got it right. All right, let's jump to number 8. We want to write an equation for a sine function that has a period of pi, vertical shift of 3, and an amplitude of 4. And our a value is greater than 0. So that tells me my a value is positive. All right, but the key is we start out with a sine function. Okay, now it does tell us our amplitude, because so that's our a that's going out in front of sine, and it's positive. So it's a positive 4, sine. All right, now our B value is always going to come from the period. That's going to be your hardest. All right, remember period equals 2 pi over B. All right, now some of you may realize, and I'm going to kind of go to this. If I multiply by B, so B times the period equals 2 pi. All right, and then I divide by the period. So B equals 2 pi over the period. Really, if I just use this formula right here, I can keep getting the B. So here, if my period is pi, in this case, if I do 2 pi over pi, that's my B value. So B equals 2, because the pi's are going to cancel out. All right, we're not saying anything about a phase shift, so I'm just going to put an X. We're not going left or right. Okay, and then here, vertical shift of 3. So it's a positive 3, so I'm just going to put plus 3. All right. Now, number 9, write an equation for a cosine function that has a period of 4 pi, midline of y equals -2, and an amplitude of a half. But this time, a is less than 0, so it's telling me my a value is negative, so it's going to be negative 1/2. This time it's a cosine function. Now, b, remember, it's 2 pi over the period, or you can do what we did yesterday. The pi's cancel out, and 2 over 4 is 1/2. So my b value is also 1/2. I don't have any phase shift or left or right, so I'm just going to put x. All right, and my midline, instead of saying vertical shift, they just said midline, is -2. And you can double check this. So if I want to, I can, all right, let's see. Let's plug this in right quick. All right, so -1/2, and then cosine of, you got parentheses around the 1/2 and then x. Close your parentheses and then say -2 on the outside. Okay, so here, now if I make it just a tad bit bigger, oops, actually, let's do this. Here, if I go here to here, all right, you'll see that this is the length of one cycle. So my period is 4 pi, like that we said we wanted it to be. If I put y equals -2, that's my midline. Does that look like it runs through the middle of it? And it does. And my amplitude is 1/2. Well, the way I have it, each block is worth 1/2. And if you notice, this distance from the midline to the max right here is 1/2. All right, so I must have done it correctly. All right, number 10, we're going to look at some real world things on this. The tides at a beach are cyclical. They're going like this. All right, at midnight, a low tide of 4 feet, while at noon, a high tide is 10 feet. Okay, so let's think about this. All right, at noon. Noon, we'll call, that's going to be 0, but we'll just say 12 noon is right here. All right. A low tide is at 4 feet. Okay, at, whoops, not noon, sorry, midnight, 12 midnight. That's when the day starts. Okay, at noon, and think noon is 12 hours later. Okay, it's at a high tide of 10 feet. Okay, but then think, if this is 12 hours later, so back at midnight, I'm going to be back here at 4. All right, so let's talk about this for a second. Well, where's our midline? Our midline is going to be somewhere right here. Okay, and where is that? That's the middle of these two. So if I take 10 plus 4 and I divide by 2, all right, that's 14 divided by 2, which is 7. So my midline is at y equals 7. All right, now that makes my amplitude. So think about this. If this is at 7 and this is at 10, what's the distance? Well, that's an A value, absolute value of A for right now, of 3. We don't know if it's negative or positive right quick yet. All right, now look down here. It starts below the midline. So we can get 2 things from this. Number 1, A is negative because it starts below the midline, but also because it doesn't start on the midline, this is going to be cosine. We're not going to worry about phase shift. All right, so here, y equals, we know that it's A is negative, so it's -3 cosine. Okay, the only thing I haven't gotten is my b value. My b value is the period over 2 pi. Well, if you notice, the period is this length right here. So my period is 24. All right, and if I use this formula up here, b equals 2 pi over the period. So b equals 2 pi over 24. That reduces to pi over 12. So b is pi over 12. We'll put x. All right, and our midline, so plus 7. All right, so if you want to graph this and see if it matches this, you'll figure out that it does. All right, now moving on to number 11. An electrical current alternates between 60 volt and 120 volt and back every 0.2 seconds. All right, so 60 volt and 120 are my max and my min. All right, I'm just drawing a sketch. It's nothing exact. Okay, so let's read this again. An electrical current alternates between 60 volt and 120 volt and back every 0.2 seconds. Well, what is that? That is our period. Okay, so 0.2. Assume the initial voltage was at 120. So it starts here at 120. All right. It'll eventually go here and then back every 0.2 seconds. All right. So let's look at this. I like to pick out the midline first. It's in the middle. Well, how do you find the middle of two numbers? Add them together and divide by 2. So that's 180 divided by 2, which is 90. This is A. All right. Not A, I'm sorry. K, or midline. All right. So Y equals 90. All right. So our amplitude is the distance from 90 to 120, or you can say from 60 to 90. All right. That amplitude, or the absolute value of A, equals 30. All right. Now, the other thing is it starts above the midline. So A is positive. All right. So we'll go ahead and start out with that. A is a positive 30. Now, is it sine or cosine? It's cosine because it starts above the midline. All right, my period. Now the length is 0.2. So we got to find that B value. So 2 pi over 0.2. And if you take your calculator right quick, and I say, I'm just going to put the number in, 2 divided by 0.2, you get 10. This makes 10 pi. All right, so that must be my B value right there. And then I'll put an X, and my midline is 90, so put plus 90. If you want to throw parentheses around that, feel free to, because if you do throw it into a graph, you would need to do that. All right, number 12, a Ferris wheel. A Ferris wheel is one of those things that you sit on, and it just keeps going around and around. All right, a Ferris wheel is 50 feet in diameter. All right, so it's sitting on something right here. Okay, 50 feet in diameter. Well, what does that mean? Well, that means 25-foot radius on either side. Okay, so just kind of remember that. With center 60 feet above the ground. So this part is 60 feet above the ground. Well, if that part's 60 feet and that part's 25, when I do 60 minus 25, I get 35. So this part right here is 35 feet above the ground. Keep that in mind. You enter from a platform at 3 o'clock position. So if you remember a clock, this is where the 3 o'clock position is. So you're entering here. You're entering 60 feet off the ground. All right. So now that is not my max height. That's actually my midline. I'm entering at 60. All right. It takes 80 seconds for the Ferris wheel to make one revolution. So let's think about this. All right, to go all the way back here, it takes 80 seconds. That's my period. My period is 80. All right, that means I can find B by doing 2 pi over 80. And if I simplify that fraction, it's pi over 40. You can put 2 divided by 80 and simplify it in your calculator. But let's think about this for a second. 20 seconds. So think if I take 80 and I divide it, because think this is kind of divided into fours. 1, 2, 3, 4. So 20 seconds later, I'm going to be at 35. All right. And then 20 seconds later, after that, I'm going to be back at 60. That's at 40 seconds. All right. And then right here, when I get to this point, 20 seconds later, that's at 60 seconds. All right. I'm going to be a height 25 feet greater than 60. So when I add that, that's 85. All right. And then at 80, I go back. So here is my graph right here. All right. So let's find all these things. Well, this time my midline is Y equals 60. That's my K value. This time also my amplitude right here, my A value. Okay. The distance between that and that, think 35 and 60 is 25. That's my, I'll say absolute value of A. But do you see how this goes below? So my A is actually going to be less than 0. It's going to be negative. So let's start out with that. It's going to be negative 25. And is this sine or cosine? It's sine because it starts on our midline. Now we found our b to be pi over 40, and I'm going to put x. Sometimes they put theta instead of x. It's just kind of up to you. All right, and then my midline plus 60, like that. Okay, last problem, number 13. A windmill, okay, that's that thing that it'll stand up and it'll be like in a farm, windmill, something like this, okay, and it goes around. It may have, it just depends on how many turbines or tines it has. I don't know what they're really called. Okay, it has a radius. A windmill has a radius of 1 meter. So if you think about, so this going around in a circle, each of these is 1 meter. Okay. And its center is 8 meters off the ground. So the center right here is 8 meters off the ground. All right. Point W starts at the tip of a blade in the farthest position to the right and rotates counterclockwise. Okay. So actually, let's start off like this. I'll do this. So this is a length of 1. Okay, it starts here. So it actually starts at 8. And I'm going to go, it said, what with a graph at the center? Oh, that's, okay. So it starts at 8 right here. We'll just say 8. And if you notice, kind of like the 8 is kind of in the middle because, and it goes counterclockwise. So I'm going to go this way. All right. The center is 8 meters off the ground. So it starts at 8. All right. The point W starts at the tip of the blade, the position farthest to the right, and rotates counterclockwise. Write an equation for a function describing the relationship between the height of W in meters and the angle of rotation. Now, here's the thing. It didn't actually tell us what theta, not theta, what B is. Okay, it doesn't tell us how long it takes. So we can't actually find this B value right here. But here, when it goes here, it's because this is 1, this is going to now be 9. All right. All right. And then here, we're going to go back to 8. All right. And then here, we're going to go, and it's going to go down to 7. All right. And then it would go back to 8 right here. So 1, 2, 3, 4. Think. Start here. 1, 2, 3, 4. There we go. There's the graph. Well, here our midline is at y equals 8. Here our amplitude is 1. All right. And here it's positive. Now, is it sine or cosine? It's sine. So y equals between the height. Okay, the height is we'll call this h, is the y value. All right. All right, we figured out our a value is 1, positive 1. Okay, this is a sine function. I don't know what b is, so I'm just going to leave it as b theta and then plus 8. All right, because they didn't tell us how long it takes to do the actual rotation. Now, what would the graph look like if the center of the windmill were 11 meters off the ground? Well, look, here when it was 8 meters, our midline, our K value is 8. Well, all this does is shifts this up to where instead of this being 8 right here, it's going to be 11. All right. And so you would have 12, 11, 10 right here. And so it would go here, we'd go here, we'd go back, go to 10. All right. And then back. So the graphs would look similar. It's just the whole graph is shifted up. So graph shifted up 3. Okay, 3 meters. And our equation would be h equals sine b theta plus 11. And again, we don't know how long it actually takes to do that rotation. So we're just going to leave the B right there. Be able to write these equations from different scenarios, be able to pick out the amplitude, vertical shift, midline, period, and so forth, be able to write the equations given some of these things as well. If you have any questions, please make sure you ask your teacher.